Welcome to a look inside the mind of one of China's most influential AI founders. Yang Zhilin is the founder and chief executive of Moonshot AI, whose Chinese name means the dark side of the moon, a Pink Floyd reference, and the company behind the Kimi chatbot and the open-source K2 model. Born in Guangdong in 1992, he studied at Tsinghua, earned a PhD at Carnegie Mellon, and worked at Google Brain and Meta AI before returning to China. He is the first author of two landmark natural language papers, Transformer XL and XLNet. A quick, honest note on this episode. The original conversation is in Chinese, so this English rendering is compiled from published English translations of Yang Zhilin's interviews and from detailed coverage of Kimi K2, rather than a word-for-word transcript of this particular recording. With that said, what follows is a faithful tour of his worldview, the scaling laws he builds on, the long-context obsession at the heart of Kimi, the open-source and agentic bet behind K2, and his vision of where AGI is heading. AI is a pile of scaling laws. Yang Zhilin's first principle is blunt. Artificial intelligence, at its core, is just a set of scaling laws stacked on top of one another. Machine learning has been researched for 70 or 80 years, and in his view, the one thing that has reliably worked is scaling, expanding the production factors of compute, data, and model size. His practical rule follows directly. If you can solve a problem with scale, don't solve it with a new algorithm. The value of a new algorithm is to enable better scaling. He frames model progress as a race up a predictable curve, where the frontier sits somewhere around 10 to the 25th to 10 to the 26th floating point operations, and where clever techniques like mixture of experts or synthetic data are simply ways to bend the cost curve, to use more parameters at the same compute, or grow the data at the same compute. Compute, he insists, is a necessary condition, but it is not the only production factor, and the winners are those who make every other factor more efficient. Every problem is a long context problem. If there is one idea that defines Kimi, it is long context. Yang argues that every problem is essentially a long context problem, and that the entire history of AI architectures has been, underneath, a story of extending effective context length. He traces the lineage. A decade ago, word 2vec used a context of about 5 words. Recurrent networks stretched that to around 20, LSTMs to several dozen, transformers to several thousand, and today's models to hundreds of thousands. He believes there is effectively a Moore's law for context length, with the crucial caveat that accuracy at a given length matters just as much as the length itself, what he calls lossless long context. Push this far enough, he says, and the implications are staggering. With a billion-token context window, most of the problems we struggle with today simply cease to be problems, and a model becomes a genuinely new kind of computer, one you could hand the entire contents of your hard drive and have it act on all of it at once. The 3 layers of AGI technology. Yang breaks the path to AGI into 3 layers, and it is a useful map. The first layer is the familiar one, next token prediction plus scaling laws, where everyone is converging and where OpenAI got a multi-year head start by committing resources early. The second layer holds the 2 hard, unsolved problems. How to represent the whole world in a general-purpose way, the way a computer represents everything with ones and zeros, which today's architectures still can't fully do, and how to break the data bottleneck through self-evolution. His metaphor for the second is memorable. Today's AI is a black box with 2 cables plugged in, a power cable and a data cable, and the next generation of AI has to unplug the data cable, so that as long as power keeps flowing in, intelligence keeps flowing out. Solve those 2, and the third layer opens up enormously. Long context, cross-modal generation, multi-step planning, instruction following, and agents, which is exactly where he believes the real differentiation and Moonshot's opportunity lies. Kimi K2, the open-source bet. K2, released in mid-2025, is the concrete expression of that philosophy and a strategic pivot. It is a 1 trillion parameter mixture of experts model, released open source, and notably a non-thinking model that doesn't generate a long reasoning chain before answering, yet was trained extensively with reinforcement learning to lead on coding and agentic tasks. Its architecture openly builds on DeepSeek's V3 work, The K2 team says there was no point reinventing the wheel when that design was already validated at scale, while pushing sparsity further, raising the number of experts because their own experiments confirmed scaling laws hold for sparsity. The open-source decision is itself telling. Yang had once been skeptical that open models could catch closed ones, but DeepSeek changed the calculus, and Moonshot's engineers put it plainly. Capability is the best form of advertisement, and open sourcing forces a higher standard, because anyone with the same weights must be able to reproduce your results. You can no longer dazzle users with superficial tricks. The model is the agent. Moonshot brands K2 as open agentic intelligence, and their guiding phrase is that the model is the agent. The intelligence shouldn't live in a wrapper around some other company's model. It should live in the weights themselves. The way they trained for this is striking. The team had the model generate hundreds of real-world scenarios, food delivery, social apps, messaging, then thousands of tools for those scenarios, then hundreds of thousands of distinct agents built from different tool sets and system prompts. They then ran massive agentic simulations. A simulated user with its own personality and style is given a task, interacts with an agent, and a tool simulator acts as a small world model returning feedback, with every interaction scored against rubrics so that only the good trajectories are kept. In short, K2 was trained on enormous amounts of synthetic data engineered to resemble real applications and optimized for tool calling. And the team's stated next step is to build large-scale agentic reinforcement learning on top of it. Data, synthetic data, and inference becomes training. The data bottleneck is central to Yang's thinking, and his projections are bold. Text data runs short first, he argues, but bringing in multimodal data buys the industry another year or two. And synthetic data is what ultimately unplugs that data cable. He expects a genuine paradigm shift. By around 2026, the computer model spends on inference may far exceed what it spends on training. You might spend 10 times as much on inference as on training. And crucially, much of that inference won't serve any user at all. Instead, inference becomes training. The model runs to generate synthetic data for its own improvement. He notes this even helps with energy, because inference can be distributed in a way that a single monolithic training run cannot. Whoever masters synthetic data generation, he predicts, gains a decisive advantage by the GPT-6 generation, potentially cutting the cost of alignment data by orders of magnitude. Personalization and trust, the real product. Ask Yang what an AI product is ultimately for, and the answer is personalization, something previous technologies never did well. He makes a provocative technical bet. Fine-tuning, as we know it, may not exist in the long run. As models get better at instruction following, reasoning, and holding context, everything you'd once have fine-tuned can instead live in memory as an ever-growing set of prefixes. Your entire interaction history simply becomes the collection of your preferences and feedback. But the real gate, he stresses, is trust. The ultimate measure of an AI product's long-term value, he says, is how much personal information a user is willing to put into it. And lossless long context and personalization are what turn those inputs into valuable outputs. You can't engineer features just to harvest information. The end state has to be that users and the AI become friends, so a person feels able to tell it anything. OpenAI's idealism, ByteDance business sense. Yang positions Moonshot with a memorable formula. He wants to build a company that combines OpenAI's technology idealism with the business philosophy of ByteDance. He rejects the idea that pursuing AGI and building a real product are means and ends. To him, they are both goals in themselves. He believes the Asian instinct for commercialization has genuine merit. If you don't care about commercial value at all, it's very hard to make a truly great product or to make great technology greater. And he ties this back to the data flywheel. Historically, almost every successful internet product ended up scaling on user data, and while base model scaling still dominates text today, he expects the balance to shift over time toward the scaling laws of user data. A company that doesn't care enough about its users, in his framing, may ultimately fail to reach AGI at all. Talent, organization, and the endgame mindset. On people, Yang's philosophy is distinctive. He values the ability to learn over accumulated experience, and by learning, he specifically means the capacity to unlearn, especially to unlearn past successes. If you built a famous product from 0 to 1, he suggests, you may actually struggle more with AI because you have so much to unlearn. He resists dividing people rigidly by role, arguing everyone in this era needs to be multifaceted, and he wants to keep the organization deliberately lean. One of his core judgments is that AGI does not require a huge headcount, and that becoming just another big tech corporation would forfeit the advantages of a small, sharp team. For researchers, the traits he prizes are focusing on the big picture while letting go of small details and holding an endgame mindset. The discipline to see, as with the long context through line, that each generation of technology is really solving the same deeper problem. A global, commoditized AGI. Finally, Yang's long horizon is expansive and optimistic. He firmly believes AGI will be inherently global. Trained across a vast range of languages and cultures, it will inevitably shape values and reshape how people spend their time, with more of life lived in digital and intellectual spaces. In the near term, he concedes a strong Matthew effect, where leading, low-cost models let early winners accumulate advantage. So within a 5-year window, the top players may dominate. But stretch the timeline to 50 years, and he expects AGI to be fully commoditized, no different from electricity today. The productivity gain, he argues, is close to certain. Where a single piece of software might today embody the intelligence of 1,000 programmers, tomorrow's applications could carry the equivalent of 1,000,000, improving themselves through endless iteration. It is a characteristically first principles view that intelligence, like the scaling laws beneath it, keeps compounding. And it is the conviction that drives everything Moonshot and Kimi are trying to build.